A teacher for more than 17 years, and he's also the e-learning coordinator and quality assurance officer in Dubai campus. Joined by Mr. Fadi Saeed. Mr. Fadi was also a lead teacher and then a teacher in Applied Technology High School at Ras Al Khaimah. Mr. Fadi also is the e-learning coordinator. I hope that with a long experience, of course, he teaches math in Lebanon and in the UAE. This is going to be a 50% theoretical and 50% practical session. We hope that our presenters will give you a good idea of how to present STEM in your classes. I hope you will enjoy it, and at the end you will kindly fill a questionnaire about feedback of what you have learned and how much you think that this was useful to your everyday. Okay guys, good luck, and please you can start so that we can keep track of time.
Thank you.
Yeah.
Thank you. Good afternoon. Good afternoon. Today, inshallah, we will talk about STEM education. We will not talk about STEM as a scientific, in a scientific way. We will learn or we will see how to apply it in our classroom as a math teachers. At the beginning, we want to know what is STEM. As you know, STEM is science, technology, engineering, and mathematics. Okay, the education. What does it mean? STEM education means the integration of these 4 domains, okay, to give the students a chance to make sense of their world, rather than learn isolated piece of phenomena. So we integrate math with other domains like technology or science. The students will understand what we learn, not just learn a pure math. No, students will be able to apply what we learn in real life situations. Okay. Now, why do we need STEM in math? Why do we need STEM in math? To make it easier. Okay.
But I think it's also to integrate and also to develop critical thinking skills.
Great.
To encourage students to solve real-world problems.
Great. Great. But why all of these ideas? Why? Because math is very abstract subject, and it's very difficult for our students to be there. Math is very abstract subject, and it's very, very difficult for our students. So we need to try to make math is easy or enjoyable for our students. How can we make it easy and enjoyable for our students? By integrating math with technology, integrating math with real life situations. For example, if we teach Pythagoras theorem, normally I come to my class and draw the triangle, and I say the square, the hypotenuse square equal the sum of the square of the 2 other sides. This is Pythagoras theorem. In this case, the theorem has no meaning for my students. It's just pure mathematics. But if I connect it with the real life situation, like what? If I give him this picture and I give him the 3 sides, and I ask him to find the relation between the length of the 3 sides. And I try to help them, the students, to to find the relation between the three sides. In this case, the Pythagorean theorem will have a meaning for the student. Now, I can come back and tell him the theorem and start solve applications on it. Another idea, if we teach limits for the students, limits, when does the limit exist? We have three cases to find the limit. The first case, 1, 2, 3. Why? Why I learn this? Because I didn't connect this idea with a real life situation, or I didn't visualize this idea. If I visualize this idea, it will be very easy for the students to understand it. Look at this video. Throughout this video, we integrate math with technology. We get the benefits from technology to make math easy for our students.
Cannot exceed 200
Look here, when I try to explain when does the limit exist, I tell the students the limit when x approaches 3, for example, limit when x approaches 3 exists when x approaches 3 positive equal limit when x approaches 3 negative. What does it mean 3 positive, 3 negative? It's very difficult. When I show them this video, it will be very easy for the students to understand the idea. That's why we try to integrate math with technology to make math easier for our students. This is the idea. No need to continue the video. Let's continue our presentation. So that's why we need to integrate math with other domains. We need to integrate math with technology, math with science, math with engineering. Now, as a math teacher, how can we apply it inside the classroom? Do you have an idea? Do you have an idea how can we apply it inside the classroom?
Anybody do science?
How can we apply steps inside the classroom? You have an idea? Okay. To apply STEM inside the classroom, me as a teacher, I have two chances. I need to apply STEM, means integrate math with other domains. The second, I want to keep continuous improvement in my work. If I apply the project today, I need to improve it. I will not apply the same project next time. I need to add something new to this project. So we choose to use Deming model to apply STEM inside the classroom. Deming is an American statistician who innovated a cycle for continuous improvement. This cycle called Deming cycle. This cycle for continuous improvement applicable in any organization, including educational organization. The Deming model depends on 4 steps: plan, do, check, and act. We will apply these steps inside the classroom. Usually plan will be outside the class before you start your lesson. So, in our case, the step of the plan, you will plan for your project. By the way, STEM is not a new approach in teaching or learning. STEM exactly the same as project-based learning. It's in our vision already. So it's not a new approach. Just we want to learn how to apply, integrate it in our classroom. The first step, the plan. You will plan, you will design, you get an idea for your project, and start arrange the required tool, the objectives, and then start design your project. These two steps will be before the classroom. Now the next step is the do. You will implement your plan. You will do it inside the classroom. You will do the project. You will ask your students to do the project. The third step, during the operation itself, you will assess the students' work. And then you will move to the next step, which is add, you will select the best projects to be demonstrated for the school, and make very important thing, which is the post-lesson activity. This activity for the teacher himself. After he finished teaching and after he finished doing the project, he will list all the good points and all the bad points and try to find solutions for the bad points. If you face any problem during the implementation, you will try to find a solution for this point. So you will take this point in consideration when you try to plan for the same project as for another class or for the next one. By applying this model, you did two things. You applied STEM integrated math with other domains, as you will see with Mr. Fadi, and you will apply the quality assurance inside the classroom. Okay. Now Mr. Fadi will go with us step by step. You will apply this model with a project step by step.